Okay, in this video we're going to look at determining the uncertainties in one of the variables expressed in graphical analysis. Okay, here I have a data set. We're looking at the relationship between d, the distance a ball rolls down a slope, and t, the time it takes to traverse that distance. Our previous work has told us that in fact t is related to the square root of d, so I've transformed my variable d by taking the square root, and now I need to transform my uncertainties. Now t does not get transformed in this relationship, so I don't need to transform its uncertainties, but d does. It gets transformed to the square root of d. And now when I take a square root function, I have to transform the percentage uncertainties. So that's the first thing I need to work out. So I've got my uncertainty in d, and now I need to work out my percentage uncertainty. And I'll just zoom in to make that a bit bigger for you. So I need to calculate what a percentage the uncertainty in d is of the d value. So that's equals, put a bracket in because we have the bed mass rules, the value of this as a fraction of that, and multiplied by 100 to make it a percentage. So 0.005 is 5% of 0.1. That's what that's telling us. And I can copy that formula down, and we've now calculated the percentage uncertainty in d. Now, because I take the square root of d, my percentage uncertainty turns out to be 0.5, a half of the percentage uncertainty in d. That's because the square root is x to the power of half, so it's a half. So half of 5 is in fact 2.5, which makes sense. So I copy that down. They're all my percentage uncertainties. And now I need to work out what 2.5% is of my square root d value. So let's do that. Equals 2.5. Put it out of 100 to make it a fraction. Multiplied by the square root of d. So 2.5% of 0.316 is 0.0079. Copy all that down. There's all my calculations done.